very good morning to all. I'm your math teachers from IYS. This is our 8th online class of mathematics. Before starting our class, first I'm sharing some instructions in front of you all. Don't raise hand during teaching. Ask questions at the end of the lesson only in chat box. Use hand-free if you are using mobile and headphone for computer use. Feed your ID and password properly with your name. Take care of time for attending the class. Home tasks should be done in your fair copy of the subject. If there is any disconnectivity during the teaching, try to join the session again within 5 to 10 minutes. Now, today we are going to start a new lesson, that is chapter number 1, sets, page number 1. So the topics of the day are: what is set, representation of set, and types of set. So what is set? A set is a well-defined class of distinct objects. Here we have used two terms, the well-defined and distinct object. What is well-defined? Well-defined means does or does not belong to that class. Simply, in a simple words, we can say that the objects belongs to the same category and they have clear and proper definition. And the second term is distinct object. So what is distinct object? There is no repetition of any object. It means that when we have same objects in a set, so we will not repeat it. We will write it only once. So a set is a well-defined class of distinct objects. It means that it does or does not belong to that class and there is no repetition of any object. So this is called set. Let's take some examples. The set of numbers. Here we have numbers 1, 2, 3. So this is a set of numbers. The set of vowels A, E, I, O, U. This is also the set. Set of even numbers 2, 4, 6, 8, 10, 12, so on. So these all are the sets. Sets should be vowels, even numbers, alphabets, whatever it will be. But always remember, sets should be well defined and distinct objects. Now, notations. Sets are usually denoted by capital letters. We always denote the set by capital letters. Letters should be A, B, C, X, Y, Z, M, N, O, P, whatever it will be. But we always denote the set by capital letters. Whereas the elements in a set are usually represented by small letters. Understood that notation? We denoted by capital letters, but the elements, we denote the elements by small letters. Let's take this example. We have example A equals to 1, 2, 3 until then 10. We have a set A equals to 1, 2, 3 till then 10. So what is notation? This A represents notation. What I have told, sets are usually denoted by capital letter. Here we have denoted our set by capital letter and the letter is A. This letter should be X, Y, Z, whatever it will be. You can use it by your own choice. Okay. Now the next one, elements. Anything belonging to a set is called an element of a member of that set. Anything which is written inside the set is known as elements, or we can call it the member of that set. Example, A equals to A, B, C till then Z. So these all are the members or elements of set A. This A represents set address, that A is a set, and the elements which is written inside these braces is known as the members of or elements of set A. So this represents elements or member of set. Representation of set. Representation of set. We have three representation of set. The first one is the tabular method, the descriptive method, and the set builder notation. We can represent a set by three different methods: tabular, descriptive, and set builder notation. The first one is tabular method. The elements of a set are enclosed within braces, separated from each other by commas. What is tabular method? Okay, the tabular method is always written within the braces and each element is separated from each other by commas. Let's suppose this is example: A equals to 2, 4, 6, 8, 10, 12. So every element is separated each other by commas. You can see these are the commas and the elements are written within the braces. These brackets are known as braces. So in tabular method we always use braces and commas. These two things are very important in tabular method. Okay, this is the set of even number, starts from 1 till then 20. Even number between 1 to 20. 2, 4, 6, 8, 10, 12, 14, 16, 18, 20. These all are the set of even numbers from 1 to 20. Again, I am repeating what is tabular method. In tabular method, sets are enclosed within the braces and separated from each other by commas. Now, the second example: 2, 4, 6 till then 18 and 20. Both are same. Okay. Note down the thing. This is very important. If the last number of a set is not known, then we write first 3 or 4 members, then put some dots within the braces. What does it mean? If you don't know about the last member, that what is the last point, what is the last element or the member of set, then what we have to do? We have to write 3 or 4 members, first 3 or 4 members, and then we put dots within the braces. No need to write 1 till then 100, 1 till then 200. Just write first 3 or 4 members and then put some dots within the bracket. For example, the set of natural numbers will be written as, here is example. Just you have to write the set of natural number. We don't know what is the last element, what is the last point. The last point is unknown. So what we have to do, we just write first 3 to 4 numbers, write 1, 2, 3, 4, 5. It's up to you that how many, but maximum 3 to 4 numbers you have to write and then put down dots till then end. When we have to do this? When we don't know about the last element of the set. Okay. Now, in descriptive method, we describe a set by statement. Which type of a statement? We use a form of sentence in descriptive method. We does not use any symbol, any letters, any numbers. We just describe a set by using a statement or in a form of sentence. Example, set of all natural numbers. This is in the form of statement. Set of even number less than 20. This is also in the form of statement. So in descriptive method, we don't use any symbol, any numbers, any letters. We just put the statement in descriptive method. Okay. The next one is set builder notation. Basically, set builder notation is a combination of letters, numbers, symbols, brackets. This is a combination of all these things. Check this example. A equals to x slash x. You can see and you don't understand what is this. Actually, this is a code words and we have to read these code symbols. And how we will read this one? A. As we all know that A is a notation or A represents the address of sets. So, how we will read it? A is the set of all x. We read it as x. And this line, this vertical line, we read it as such that x is a natural number and x is less than 10. This sign, this symbol represents the sign of less than. And what is the last range? The last range is 10. As we all know that these are natural numbers. So how we will read it? A is a set of all x such that x is a natural number and x is less than 10. X such that x is a natural number less than 10. So these are the code words and we have to read these code words like A is the set of all x such that x is a natural number and x is less than 10. So this is set builder notation. Now the set of numbers. Okay, we have some commonly used sets of numbers and we have denoted by their particular names. So what are these set of numbers? We have already discussed these three methods: tabular, descriptive, and builder notations. So one by one, we will discuss the set of numbers. The first one is n. N represents natural numbers. Natural numbers are simple numbers like 1, 2, 3, 4 up to infinite. Natural numbers are infinite. So right now this is in the form of tabular method. What is the descriptive form of this set of numbers? We will write it set of all natural numbers. And what is the builder notation? The builder notation, okay, you can use these alphabets to your own choice. You can use X, Y, Z, A, B, C, whatever you want. I have used N. So you can write A, B, X, Y, Z. It's up to you. So N such that N is a natural number. We don't have the last range. We don't have the last point or last element. So we will not write the last element here. We just write N such that N is a natural number. The next one is W equals to 0, 1, 2, 3. W. What is W? This W represents whole number. W represents whole number. Students, whole number always it starts from 0. What is the difference between natural and whole number? Natural number starts from 1, 2, 3 and the whole number it starts from 0. 1, 2, 3 till then infinite. So what is the descriptive form of whole number? Set of or all whole numbers. Why we are using all? All means this is infinite. We don't know what is the last range. So we will use all whole numbers. Set builder notation. Here I have used X as I have already told. You can use any alphabet. So x such that x is a whole number. Now z equals to -2, -1, 0, 1, 2, 3. What is this? The z represents integers. Z is a symbol of integer. So we have two type of integer numbers, as you have already know, positive integers and negative integers. So -2, -1, these are negative integers, and 0, 1, 2, 3, 4, these are positive integers. So how we will write it in the form of descriptive method? Set of all integer numbers. Again, I'm repeating, when we don't have the last point, we don't have the last element, we will use all. So it means this is the set of all integer numbers. Builder notation A such that A is an integer. The next one is O equals to 1, 3, 5, 7. So what is this O? This O represents odd number. What is odd number? The number which is not divisible by 2. 1 is not divisible by 2. 3 is not divisible by 2. 5 is not. 7 is not divisible by. So that type of numbers which are not divisible by 2 are known as odd numbers. Like 1, 3, 5, 7, 9, 11, 13. So these all are odd numbers. So these are also set of all positive odd numbers. Why? Because these all are positive numbers. So Z such that Z is a positive odd number. These are alphabets. You have to write it by your own choice. This is not permanent alphabets. You can choose it by your own self. Now, E equals to 2, 4, 6, 8. E represents even number. Even numbers are opposite of odd number. Odd numbers are not divisible by 2, but even numbers are divisible by 2. Like 2, 4, 6, 8, 10, 12, 14, 16, 18, 20. These all are even numbers. So, set of all positive even numbers. The builder notation of this is y such that y is a positive even integer. These are positive integers. You can see that. Now C equals to 4, 6, 8, 9. C represents composite number. Composite numbers mean those numbers which have more than two multiples. Which have more than two multiples like 4. 4 have more than two multiples. How? The multiple of 4 is 1, 2 and itself 4. So more than two multiples are known as composite number. So these are set of all positive composite numbers. So P such that P is a composite integers. So these are the set of numbers. Now the next is types of set. We have three types of sets. First one is finite, second one is infinite, and the third one is null set. What is finite set? If the number of elements of a set is limited, it is said to be finite. As I have already told in the previous slide that if the last range is given, if the last element of the set is given, it means that set is known as finite set because we know the limitation of that set that it start from 1 and it's end till then 10. If we know the last element, then it means that this is a finite set. For example, A equals to 1, 2, 3, 4. It starts from 1 and it ends till then 4. So this is finite set because here we have the last element. The next one is infinite. What is infinite? If the number of elements of a set is limited, it is said to be infinite. Element of set is limited means that we don't know if the number of elements of a set is not limited. It is said to be infinite. It means that we don't know about the last range. Last range means the last element, which I have already told you that if you don't know about the last element, it means that set is known as infinite set. For example, A equals to 1, 2, 3. Here you can see that the last range is not given. Dot, dot, dot represents this is infinite set. We don't know what is the last element of that set. The last one is null set. What is null set? A set without element is called a null or empty set. It means a set which have no element, no member inside the braces. So this set is known as null set. For example, you can see this braces, there is no element inside the braces. So this is null set. Not even any one element within the braces is known as null set. And we can also represent null set by this symbol that is known as phi. You can represent null set by these empty braces and this symbol phi. So these are the three types of set. Now we have some symbols and how we can read it. So these are the symbols. The first one is U. U represents union. We can read as union. This sign represents less than. This symbol, this sign represents as greater than. This vertical line represents such that this is equals to. N represent natural number, which we have already discussed in the previous slide. W represents whole number. O represents odd numbers. Z represents integer numbers. E even number. C composite number. P prime number. Okay, prime number. What is prime number? Prime numbers are those numbers which have only two multiples. Two multiples means the one is itself on and the second one is 1. Prime numbers are those which have only two multiples, 1 and itself. And the prime numbers are 2, 3, 5, 7, like so on. So these all are prime numbers which have only two multiples, itself and 1. Okay, this symbol represents less than or equals to. This symbol represents not equals to. This is null set. This is intersection, opposite U. This E represents belongs to and this E represents not belongs to. So these all are the symbols and how we will read it we have discussed in these slides. So it will also help you in builder notation method. Okay, now we are going to start our exercise 1.1. It is on page number 3. Question number 1. The question number 1 is A equals to A, B, C. We have a set A and the element of the set A are A, B and C. Then state whether each of the following statements is true or false. Okay, here in this question we have to whether that the statement is true or false. So what is the statement? The statement is A belongs to A. As we have already know, small alphabet, small element represents element of the set and this capital A is the address of sets. So the question is A belongs to A. Does A belongs to set A? Look at this statement. Yes, it is true because this A belongs to set A. So the answer is 2. Let's suppose we have a statement that Z belongs to A. So that Z is inside the braces. Z belongs to A? No. So here we will write false because Z is not the element or the member of set A. The next one is, okay, question number 2 is your home task, MCQs based question. You have to do it by your own self. We are starting question number 3. The question number 3 is, write the following sets in tabular form. So we have already discussed what is tabular form. So the question is, C equals to set of prime numbers less than 10. You can easily see that the question is in the form of descriptive, like in the form of a statement, and we have to convert this statement in the form of tabular method. So, what is the requirement of tabular method? We will use braces and separated the elements from commas. So, the answer is, okay, set of prime numbers less than 10. What are prime numbers? 2, 3, 5, 7. Why we have stopped here till then 7? Because it is written in the statement that the last range is less than 10. It means the value which is smaller than 10 and the last value is 7. If we will see the next one, the next prime number is 11 and 11 is greater than 10. So we will stop it here till then 7. So the answer is 2, 3, 5 and 7. Now question number 4, write the following set in descriptive form. C equals to minus 5 dot 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 minus 1 0 1 dot 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 5. What you can see that we have two type of integer number here, the negative integer numbers and the positive integer numbers. So it means that we have two statements here. The statement 1 is set of integers greater than minus 6 and the second statement is less than 6. So how we will write in the form of descriptive? Set of integers greater than minus 6 and less than 6. The next question 5, express the following sets in tabular form. It is right now it is in the form of set builder notation. So we have to convert it into tabular form. Read down the statement. What is the statement? Y such that y belongs to prime number, y is less than 15. We have to write the prime numbers which are less than 15. So 2, 3, 5, 7, 11 and 13. Now I am sharing the home task. Then, okay. So the home task is, student, note down the home task first. What is your home task? You have to do exercise 1.1, page number 3. Question number 1, all parts. Question number 2, all MCQs you have to done in your fair copy. Question number 3, all parts. Question number 4, all parts. Question number 5, all parts. And question number 6, all parts. You have to do the all parts of all these questions in your fair copy. Kindly take the screenshots for saving the time. Then we will continue our question. Okay. Again, I will show you the slide after a few minutes. First, we have to continue our question. Okay. The last question, question number 6. The question number 6 is, denote the following set by set builder notation. So, we have a question, b equals to 1, 2, 3 till then 100. As we all know that these are natural numbers which start from 1 and the last range is given 100. So how we will write in the form of set builder notation? We will use any alphabet x such that x belongs to natural number and x is less than or equals to 100. This means these are the natural numbers which is almost equals to 100 or it can be less than 100. So this is in the form of set builder notation. Now student, what you have to do? You have to do the remaining all parts in your fair copy. Again, I am showing you the home task. Kindly take the screenshot. Inshallah, we will continue our lesson tomorrow. Till then, take care and Allah Hafiz.